Aether comes with a non-sequential raytracer, which we call Celine. To access this, we just need to click on this button on the left here, and we get this window. On the left, we have the control panels, which contain all the different options of the simulation and of the scene. On the right, we have the 3D view, which will display the scene as we add elements to it. First, I'm going to add two materials. This is done by accessing the refractive index dialog over here. The first one I'm going to call air will have a refractive index of 1, and the second one, which I'm going to call glass, will have a refractive index of 1.5. Now, to add an element to this scene, I need to select the kind of element I want to add. So I'm going to add a point source first and click on Add next to it. We get a dialog which contains various options to control the element and its location. So I'm going to set the location of my source at -300 millimeters, and we see it appearing in the scene on the left here because the center is over there. Next, I'm going to add a lens to this scene, and I'm going to put it at 0. And my scene is basically ready. I can click on Trace, and we see our first computation. Next, I'm going to click on Auto to change the color of the rays depending on their number of interactions with the different objects. And what we see is that basically nothing appeared here because we didn't actually assign a material for the lens. To change this, we need to go into its properties and into the interfaces tab, and I'm going to select the inside material through this button here. When I do this, glass has been assigned to the proper interfaces, and when I click on Trace again, we can see now that we have some reflection and the rays going straight after the lens because the source is basically at the focal point of this element. Now, Celine is a non-sequential raytracer, which means it's going to compute the interactions with all the objects in my scene, and I'm going to demonstrate this by adding a rectangle, which I'm going to displace by 150 millimeters, and I'm going to rotate by 45 degrees. I'm also going to set it as a mirror, and if I click on Trace now, we can see that we have rays that have gone through the lens and hit my mirror and have been reflected at 90 degrees. We also see some ways that doesn't seem to intersect this mirror. Their length is defined through the parameter losses at the top left, and at the moment they are displayed only with a length of 100 millimeters. If I wanted them to be longer, I will need to change this value, and we can now see all the rays that didn't hit my mirror and those that hit the mirror and propagate further. We can change, if we want to, the location of the source. So I'm going to move it further from my lens and trace again. What we can see now is that we only have a few rays in our scene. This is because the number of displayed rays is actually the maximal value that can be displayed, but it depends on the actual number of rays that hit the optical elements. Since the source is very far and we are only computing 10,000 rays in total, only a few of them actually hit the lens, so only a few of them are computed. To increase the number of rays that we want to see, we need to increase this parameter and trace again. And now we have a large number of rays again. And of course, I can increase this further to better display, for instance, the reflected rays. I see. So that's basically it. It's a very simple scene. It doesn't contain any sensor, but it helps visualize the different passes and getting a feel